Hi, myself Dr. Dhananjay Rao, working as assistant professor in the Department of Chemistry. Today I am going to teach natural rubber and vulcanization. In this I am going to cover what is rubbers and what is natural rubber and what is the vulcanization process and elastomers are synthetic rubbers and bunized rubber synthesis and its properties and applications of bunized rubber and thiol rubber, its synthesis, properties and applications. In this topic I am going to cover these. What are those? Rubber, what is the definition of rubber and what is the natural rubber and what is the process of vulcanization and what is elastomers are nothing but synthetic rubber and bunized rubber synthesis, properties, applications of bunized rubber and thiol rubber, its synthesis, properties and applications. See, rubbers. What is meant by rubber? Rubber is a common name. But elastomer is a technical name. Rubber is a common name and the elastomer is nothing but the rubber. The elastomer is a technical name. Polymers which will have rubber-like elasticity are called elastomers. What is elastomers? The polymers which will have the rubber-like structure like that elasticity are called elastomers. Okay, the polymers which contain elasticity nature are called elastomers. Technically, elastomers are defined as those polymers which are capable of being stretched at least 150% of their original length. If the elastomers are, if you stretch 150% of their original length, okay, the without breaking and retain the original shape, it will not break. Okay, now if you stretch the rubber or elastomers up to 150% of their length, okay, if you stretch 150% of their original length, okay, without breaking in the length, and retained the original shape on release on stress. It retained the original shape on release of stress are known as elastomers. What is elastomers? If stretch the elastomers up to 150% of their original length, okay na, the length of the polymer or the elastomer will not break and the retained the original shape. It retained the original shape after releasing the stress is called elastomers. Natural rubber. What is meant by natural rubber? See, it is obtained from the tree as a latex. The natural rubber is obtained from the tree, okay, as a latex, which is dispersion of isoprene. The monomer present in the natural rubber is isoprene. During the treatment of latex, these isoprene molecules undergo polymerization to form long coiled chain of polyisoprene. Okay, the latex, first we have to collect latex from the tree. Okay, then we have to do treatment. Okay, now we have to do treatment. Okay, then we will get the isoprene molecules. The isoprene molecules in the latex will undergo polymerization. It will form long coiled chain of polyisoprene. Is called natural rubber. Okay, how we can prepare natural rubber? First we have to collect latex from tree. Okay, then we have to do some treatment for the latex. Okay, the molecules present in the isoprene molecules present in the latex will undergo polymerization. It will form, okay, a long coiled chain, that is called polyisoprene or natural rubber. Okay, then next process is vulcanization process. What is vulcanization? See, it is a process of improving the properties of rubber. Okay, it is the process of improving the properties of rubber compound with the same chemical like sulfur, hydrogen sulfide, benzyl chloride, etc. Okay, by the addition of these compounds like sulfur, hydrogen sulfide, benzyl chloride, etc. It is a process of improving properties. What are the properties? Like elasticity property, resistance properties. Okay, the rubber contain the properties are increased by the, okay na, by addition of these chemicals like sulfur, hydrogen sulfide, benzyl chloride, etc. Okay, the most important is the addition of sulfur. Okay, it is the process of improving properties of a rubber. Okay na, we improve the properties of a rubber by adding some chemicals like sulfur, hydrogen sulfide, benzyl chloride, and okay, this type of chemicals if you add, the properties present in the rubber will be increased. Okay, that process is called vulcanization. Mainly most important addition is sulfur. The vulcanization was discovered by Charles Good in year 1839. The vulcanization was discovered by the Charles Good. Okay, na? The scientist name is Charles Good. In the year of 1839, he discovered the vulcanization process. What is vulcanization process? It is a process of improving the properties of a rubber by addition of chemicals like sulfur, okay, benzyl chloride and hydrogen sulfide, etc. Okay, vulcanization process of improving properties. Okay, rubber properties. It was discovered by the Charles Good in 1839. The Charles Good, okay, the scientist Charles Good observed that when rubber is heated with sulfur at 100 to 140 degrees centigrade, okay, the Charles Good discovered that one, if the rubber is heated at 100 to 140 degrees centigrade in presence of sulfur, what happens? Its tensile strength, elasticity and resistance to swelling are increased tremendously. Okay, the rubber, natural rubber is heated with the sulfur molecule in presence of heat at 100 to 140 degrees centigrade. What he observed? The elasticity of a rubber and resistance of a rubber and swelling of a rubber is increased tremendously compared with starting rubber. Okay, these properties are increased by the addition of sulfur. Okay, the Charles would observe that what happens if the rubber heated with sulfur in presence of 100 to 140 degrees centigrade. What happens? The strength of rubbers like elasticity, resistance, these properties will be increased. He observed that one. Okay. The sulfur combines chemically at the double bond in the rubber molecule, bringing about excellent changes in properties. Example: resistance, changes in temperature, increased elasticity and tensile strength, durability and chemical resistance. What happens if the sulfur added to the natural rubber or polyisoprene? What happens? These properties, the rubber properties like the what happens? Resistance increase in elasticity and tensile strength of the rubber, durability of the rubber and chemical resistance. All those properties of a rubber increased by the addition of sulfur to the natural rubber. That process is called vulcanization. See, what is natural rubber? Natural rubber nothing but polyisoprene. Polyisoprene. Okay, natural rubber nothing but polyisoprene rubber. How you can prepare this natural rubber? First, you have to collect latex from the tree. Okay, na? Then you have to give some treatment to this latex. The molecules isoprene present in this latex will undergo polymerization, form this natural rubber or polyisoprene. See, the structure of isoprene is CH2, CH double bond, CH2, CH3. Okay, na? This is the structure of isoprene. Okay, two molecules of isoprene. Okay, many molecules of isoprene will undergo polymerization. It will form the polymer like structure. This is called polyisoprene. This is the polyisoprene or natural rubber. Polyisoprene or natural rubber. What are the monomers present in this polyisoprene or rubber, natural rubber? See, these are the monomers. What are the monomers? Isoprene is a monomer. Okay, this is the structure of natural rubber or polyisoprene. This is the unit of isoprene. Okay, this is the unit of isoprene. This poly number of isoprene polymerization, undergo polymerization, it form polyisoprene or natural rubber. See, this is one linear chain of natural rubber or polyisoprene, and one more is other one is also one polyisoprene long chain. This is one long chain. This is one long chain of the polyisoprene. Okay. Then if you add sulfur and heat it at 100 to 140 degrees centigrade, we have added sulfur to this molecule. Okay. This polymers and heated at 100 to 140 degrees centigrade. What happens? See, the sulfur addition takes place at these double bonds. Okay, at these two double bonds. See, the sulfur added at these two double bonds. Okay, see how it will form. See, CH2 CH3 double bond CH and CH2 like that. One more chain is CH2 CH3 double bond CH and CH2, like one more chain is there. Okay, then what happened if you add sulfur? We are adding S2 to this polymer. Okay, what happens? Instead of these double bonds, these double bond converted into single bond. Similarly, these double bond converted into single bond. Okay, the sulfur S2 molecules added to this double bond like this, S S S, and this S S S like this. Instead of double bond, the sulfur linkages takes place. Okay. Instead of this double bond, this sulfur linkages takes place. See here, instead of this double bond, these sulfurs, S2 sulfurs, are linked to these double bonds. Okay. The sulfur or cross linkage takes place. The cross linkage of sulfur takes place in the vulcanization process. What happens? If you add sulfur to the polyisoprene molecules, okay, the if you add sulfur to the polyisoprene molecule, heated at 100 to 140 degrees centigrade, what happens? The double bond present in this natural rubber or polyisoprene, okay, those are replaced by these sulfur cross linkages. Those are replaced by the sulfur cross linkages. This process is called vulcanization. After vulcanization, what happens? The rubber tensile strength and resistance durability will be increased. Okay, that is the use of the vulcanization process. See, elastomers are synthetic rubber. What is elastomer? See, elastomer nothing but synthetic rubber. And elastomer is an vulcanization man-made rubber. What is elastomer? Elastomer is a man-made rubber or synthetic rubber. Okay, which can be stretched to at least twice its length. Okay, na? We can stretch up to the 2 times to their original length. Okay, na? We can stretch this polymer. Okay, these elastomers can be stretched up to their 2 times of their original length. Okay, but it returns to its original shape and dimensions as soon as stretching force is released. Okay, na? If the stretching force is released, what happened? It returns to its original length. Okay, there is no change in their shapes. Okay, that is called elastomer. Elastomer is a synthetic rubber. The example for one elastomer is Buna-S rubber. Okay, example for the elastomer is Buna-S rubber. Elastomers are man-made polymers or man-made rubber, synthetic rubbers. Okay, example for elastomer is Buna-S rubber. See, it is probably the most important type of synthetic rubber. It is a most important synthetic rubber or synthetic elastomer or elastomer, which is produced by copolymerization of butadiene. Okay, copolymerization of butadiene 75% by weight. Okay, and other one is styrene 25% by weight. It is a copolymerization. Copolymerization means in that polymer two types of monomers. Okay, two types of different monomers. See, one is butadiene, other one is styrene. Okay, one monomer is butadiene, other one is styrene. Okay, those polymers are called copolymers. Okay, those polymers are called copolymers. Okay, in this the butadiene percent is 75% by weight and 25% by weight is styrene. We have to add these two things. What happens? See, from nothing fun. Buna, yes. Okay. Nothing but butadiene. Nothing but butadiene. Okay. Na nothing but sodium metal. Okay, na? The Na nothing but sodium metal. That is catalyst in this copolymerization process. Sodium is the catalyst used in this synthetic process. Okay, the S nothing but styrene. Okay, S nothing but styrene. Buna is nothing but Buna, yes. Bu nothing but butadiene. Na nothing but sodium metal. S nothing but styrene. What are the monomers present in this Buna S rubber? In the Buna S rubber, two monomers are there. One is butadiene, other one is styrene. The percentage of weight of butadiene is 75% we have to take, and the styrene percentage we have to take is 25% we have to take. And the catalyst sodium metal is the catalyst in the polymerization of this process. Okay, this is the synthesis of Buna-S rubber. See, butadiene, okay, butadiene reacts with styrene in presence of sodium metal. In presence of sodium metal, it will give the Buna-S. Okay, Buna-S rubber. See what happens? The catalyst is sodium catalyst. See, this is single bond separated by two double bonds. So the delocalization takes place of this double bond. Okay, here the electrons attached to here and like this. See, the compound becomes CH2. This double bond becomes single bond and CH. This single bond becomes double bond and this double bond become single bond. Okay, CH and these attack to this styrene molecule. Okay, CH2 and this is the benzene. Like that it will continue. Okay, it will forms polymer. Okay, this is the structure of Buna-S rubber. This is the structure of Buna-S rubber. What are the monomers in the Buna-S rubber? Bu nothing but butadiene. Okay, Na is the sodium metal, that is a catalyst. S nothing but styrene. Two monomers are present. One is butadiene, other one is styrene. The butadiene percentage is the butadiene. This is the butadiene. Okay, other monomer is styrene. Okay, the metal is sodium metal. Buna-S. Buna-S. Bu nothing but butadiene monomer. S nothing but styrene monomer, and Na is the catalyst used in this synthetic process. The butadiene percentage, weight percentage 75% we have to take, and the styrene percentage 25% we have to take for the synthesis of Buna-S rubber. See the properties of Buna-S rubber. The Buna-S rubber possesses high abrasion resistance and high load bearing capacity and resistance. The Buna-S rubber contain high abrasion resistance, high load bearing capacity and high resistance. It gets readily oxidized, especially in presence of O3 present in the atmosphere. Okay, the Buna-S rubber undergo oxidation in presence of O3 or ozone. Okay, trace amount of O3 present, that will undergo oxidation. It swells in oils and solvents. The Buna-S rubber is swells in oils and solvents. And the uses and applications of Buna-S rubber. The uses and applications of Buna-S rubber. See, the major applications of styrene rubber is in manufacture of tires. Okay, the major application of the Buna-S rubber is manufacture of tires. It is used in footwear industry for making shoe soles and footwear components. We can prepare footwear components by using this Buna-S rubber. It is also used for making wires and cable insulators. By using Buna-S rubber, we can prepare or synthesize wires and cables and insulators. Okay, by using Buna-S rubber we can prepare these insulators, cables like. Okay, it is also used for the production of floor files, tank linings in the chemical industry. By using this Buna-S rubber we can prepare floor files, tank linings and chemical industries. Okay, these are the properties and applications of Buna-S rubber. The next, the elastomer is thiacol rubber. Okay, polysulfide rubber, and also thiacol rubber or polysulfide rubber. See, it is prepared by the condensation polymerization of sodium polysulfide. This is the structure of sodium polysulfide and ethylene dichloride. Okay, ethylene dichloride. See, Na. This is the structure of sodium polysulfide and dichloroethylene or ethylene dichloride, that is CH2Cl dichloroethane or ethylene dichloride. Okay, this is the structure of ethylene dichloride. Okay, these are the monomers present in the thiacol rubber synthesis. What are those monomers? One is 1,2-dichloroethane, other one is sodium polysulfide. Okay, see, in this elastomer, sulfur forms a part in the polymer chain. In this elastomer, okay, in this thiacol rubber synthesis, sulfur forms a part of polymer chain. Okay, the sulfur attack takes place here. Okay, see, this is the structure of 1,2-dichloroethane reacts with sodium polysulfide. This is the sodium polysulfide and one more 1,2-dichloroethane molecules. Okay, 1:2. 1:2 reaction. One is sodium polysulfide. One is sodium polysulfide. The two is 1,2-dichloroethane molecules. 1:2 type of reaction. These two, okay, the 1,2-dichloroethane and sodium polysulfide undergo polymerization. It will form the thiacol rubber. See, it NaCl elimination takes place from here, minus NaCl. Here sodium and Cl, minus NaCl takes place. What happens? Cl, CH2 linked to SS and CH2 Cl. This is the structure of thiacol rubber. Okay, what happens? These two monomers, 1,2-dichloroethane, sodium polysulfide reacts together. Okay, the elimination of sodium chloride takes place and forms the thiacol rubber. The other name of thiacol rubber is thiacol ethylene polysulfide polymer or sodium chloride. So sodium chloride is a elimination here. The byproduct is sodium chloride. The properties of thiacol rubber. See, these rubbers possess strength and immunability to gases. It contains, the thiacol rubber possess high strength and impermeability to the gases. This rubber cannot be vulcanized because its structure is not similar to the natural rubber. Okay, this will not undergo any vulcanization process. But the natural rubber, polystyrene rubber will undergo the vulcanization because it contains double bonds. Even though bunized rubber also will undergo vulcanization because there is a double bond. So in place of double bond, the cross linkage sulfur will be replaced. Okay, but in this structure there is no double bond, so it will not undergo any vulcanization process. This rubber cannot be vulcanized because its structure not similar to the natural rubber, and it cannot form the hard rubber. It cannot form the hard rubber. It possesses extremely good resistance to mineral oils, fuels, oxygen, solvents, ozone, and sunlight. It possesses extremely good resistance. Okay, compared with bunized rubber, it will possess extremely good resistance to the oils, fuels, oxygen, solvents like ozone and sunlight. Okay, applications. These are the applications. See, fabrics coated with thiocol are used for the barrage balloons. Okay, fabrics coated with thiocol. Okay, the thiocol rubber is coated with fabrics. Okay, these are used for the barrage balloons. These are used for the barrage balloons. It is mainly used as a solid propellant fuel for the rocket. It is mainly used for the solid propellant to the fuel, solid propellant fuel for the rocket. It is also used for making gaskets, hoses, cable linings and tank linings, etc. By using these thiocol rubbers, we can make gaskets, hoses, cable linings and tank linings, etc. It is also used for printing rolls. It can also use it for printing rolls. By using this thiocol rubber, we can print the rolls. Containers for transporting solvents. Okay, now we can prepare containers for the transport the solvents. Okay, uses. What are the uses of the thiocol rubber? See, fabrics coated with thiocol rubber are used for the barrage balloons and life rafts and jackets which are infected by CO2. Which are infected by the CO2. We can prepare barrage balloons, life crafts and jackets by using these thiocol rubbers. The thiocols are also used for lining hoses for conveying gasoline and oil. Thiocols are also used for lining hoses for conveying gasoline and oil in paints. For gaskets and seals in contact with solvents for printing rolls. By using thiocol rubber, we can prepare printing rolls. These are the applications of the thiocol rubber. In this topic, what I have covered: the definition of rubber and the natural rubber, the natural rubber, how we can prepare natural rubber, and what is the vulcanization process, and elastomers and synthetic rubber and bunized rubber synthesis and applications, thiocol rubber and its synthesis and applications. See, what is rubber? Rubber is a common name. The elastomer is a technical name. Okay, the polymers which contain rubber like elasticity structure, those are called rubbers or elastomers. Technically, elastomers are defined as those polymers which can capable of being stretched 150%. Okay, now if you stretch the polymer, okay, if you stretch the polymer, it will elast up to 150% their original length and without breaking that original length and retain it to original shape after releasing this stress. What is natural rubber? Natural rubber obtained from the trees. Okay, na, first we have to collect latex from the trees. Okay, na, then we have to do some treatment to this latex. The isoprene molecules in the rubber will undergo polymerization. It will form polyisoprene or natural rubber. What is vulcanization process? Vulcanization process, it is a process of improving the properties of the rubber. It is the process of the improving the properties of a rubber by addition of chemicals like sulfur, hydrogen sulfide, benzyl chloride, etc. Okay, this is discovered. The vulcanization process is discovered by the Charles Goodyear in 1839. Okay, see, this is the example for the vulcanization. See, this is the natural rubber or polyisoprene. Okay, if we add sulfur to this polyisoprene or natural rubber, what happens in the double bond? Okay, the double bond is replaced by the sulfur molecules forms sulfur cross linkages. It will undergo vulcanization. Okay, after vulcanization, what happened? There is an increase in the elasticity. Okay, and the tensile strength, durability. These properties will be increased on addition of the sulfur to this natural rubber. The elastomer. What is elastomer? Elastomer nothing but synthetic rubber. Elastomer nothing but synthetic rubber. These are the example for the elastomers. BNIS is the example for the elastomer. In the BNIS, there are two monomers are there. One is butadiene, other one is styrene. The catalyst is sodium. In BNIS, S rubber, B nothing but butadiene, N nothing but sodium catalyst, S nothing but styrene. Okay, this is the structure of Buna S. This is the structure of Buna S rubber. Okay, Buna S rubber can be synthesized from the butadiene and styrene in presence of sodium catalyst. These are the properties of the Buna S rubber, and these are the applications of the Buna S rubber. See how you can prepare thiacol rubber. In the thiacol rubber, these are the monomers. 1,2-dichloroethane is one monomer and sodium polysulfate is one monomer. These two monomer in 1:2 ratio undergo polymerization. It will form thiacol rubber. It will form thiacol rubber. The byproduct is thiacol rubber synthesis is sodium chloride. See, these are the properties of the thiacol rubber. These are the applications of the thiacol rubber, and these are the uses of the thiacol rubber. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.